This lab tutorial is about how to measure the gain of an AC circuit. Let's look at this first-order low-pass filter circuit. We're interested in the AC gain of the circuit. Firstly, let's calculate the gain of the circuit theoretically. We can convert the circuit into AC into phasor domain. We know the impedance for the resistor is just the resistance. The impedance for a capacitor is 1 over j omega c. Let's assume that for this AC circuit, the frequency is 1.5 kilohertz sinusoidal signal. So the input signal is a sinusoidal signal at 1.5 kilohertz. The frequency omega should be 2 pi times 1.5 k. Capacitance is 0.02 microfarad. Let's convert it to standard unit. So we got negative J 4.282 kilo. So we just convert all the components in the circuit into phasor domain. Let's look at the capacitor and the 3.3 kilo resistor. They're connected in parallel because they share the same pair of nodes. So we can combine the two impedances in parallel. So the two impedances in parallel is just the product of the two impedances over the sum of the two impedances. So ZC plus ZR. ZC is negative J 4.82 kilo multiplied by 3.3K divided by ZC plus ZR. So here should be plus. So the impedance, we can express it in polar form. We got the magnitude, which is 2.72 at a phase angle negative 34.4 degrees. Here should be negative angle. The unit is kilo. The gain of the circuit in phasor domain is output voltage over input voltage. That should be, for the inverting amplifier, should be Z over negative Z over 1 kilo. So negative Z is, we have just compute the impedance over the input impedance, 1 kilo. So it's negative Z, 2.72 at negative 34.4 degrees over 1 kilo. So we got 2.72 at, so here should be negative 34.4 degrees. I made a mistake here. So the impedance should be negative 34.4 degrees. So here, negative 1 is 180 degrees really. So we got output voltage over input voltage in polar form is 2.72 at 145 degrees. If we try to calculate the gain, we got the polar form, the gain of the circuit in phasor domain. So here we can try to measure the gain of the circuit separately by measuring the ratio of the voltages and also the output voltage phase angle with respect to the input voltage. So let's look at this circuit. The input signal should be sent to 1 kilo resistor. There's only one op-amp in the circuit, so we can use the first op-amp in the TL072 chip. So we use 1, 2, 3 pins. Notice the TL072 has to be powered with the positive 15 and negative 15 power supplies. So pin 8 should be connected to positive 15. Pin 4 should be connected to negative 15 volts. And common ground should be connected to pin 3. That is the blue wire in the circuit. So it should be grounded here. This are the signal grounds. So the input signal is, there's 1 kilo ohm resistor between the input and pin 2. So the input signal should be sent here. We have a capacitor across pin 1 and 2. So between pin 1 and 2, there is the capacitor. Between 1 and 2. And we have a 3.3 kilo ohm resistor between pin 1 and 2. It is not very clear in this picture, but actually the resistor is underneath the capacitor. Firstly, we need to power the op-amp chip. So the dot indicate pin 1 starts here. So 1, 2, 3, 4, go back 5, 6, 7, 8. So pin 8 should be connected to positive 15 volts. So we can use the 25 volts power supply in the edge-linked power supply. So it should be connected here. We can adjust it to positive 15 volts. So pin 4 should be connected to negative 15 volts. We can use the negative 25 volts power supply here and adjust it to be negative 15 volts. The input signal of the circuit should be sent to the 1 kilo ohm resistor. The output should be obtained through pin 1. So here we are interested in the gain of the circuit. That is the output voltage over the input voltage. So we need to show both of the input and output on the scope. The input should be 1.5 kilo ohm, 1.5 kilohertz sinusoidal signal. So we connect the function generator output here and with reference to common ground. So the positive lead and negative lead of the function generator are connected. So we'll adjust the output frequency of the function generator to be 1.5 kilohertz. So now we will measure both the input voltage and output voltage on the oscilloscope. So here's channel 1 is connected to the input signal. So the positive lead is connected here. The negative lead is connected to all the signal common ground. So the second channel is connected to the output voltage through pin 1. So here the first channel of the oscilloscope is connected to the input voltage. The second channel is connected with the output voltage. So that is pin 1 with reference to the common ground. So we have just made our connections here. Now let's look at the waveforms on the oscilloscope. The input voltage and output voltage. Input voltage is on channel 1, output voltage is on channel 2. We want to show both of the magnitude of the voltages. So we can use peak-to-peak value here. We are interested in the ratio. So as long as we use peak-to-peak for both of the voltages, we can calculate the ratio. So peak-to-peak 2 is 5.37. Peak-to-peak 1 is 1.91. Then we select phase angle is 146 degrees. So the input voltage and output voltage peak-to-peak values we just recorded here. Output voltage peak-to-peak value is 5.37. Input is 1.91. The phase angle is 146 degrees. That's the output voltage phase angle with respect to the input voltage. It's an offset. We can calculate the amplitude ratio is 2.81 at 146 degrees. We can compare the measured gain of the circuit to the theoretical value, the nominal values. We need to calculate the error percentage